see Keith here, but he's with the local engineering firm Wiley & Wilson, doing a lot of the legwork here in Lynchburg. First, I'll give you a little bit of a history about Lynchburg's CSO program. CSO stands for Combined Sewer Overflow. And we have a long-term control plan that we have to follow and meet the requirements of, and then we have a consent order from Department of Environmental Quality that implements the long-term control plan and dictates things like your sewer rates, what we have to do to be in compliance with the long-term control plan and complete the CSO program. So what is a CSO program? What is CSO? So basically you have, when the sewer lines were originally constructed back in the mid to early 1800s, it was really state of the art because at that point there were no sewage treatment plants. So the idea was to get the polluted water away from populated areas as quickly as possible. So basically what they did was they built one pipe system for stormwater and also sanitary sewer, so whenever it rained, it helped flush the sewage out of the pipe and into the nearest stream and ultimately the James River. A little more background, there's about 860 CSO communities nationwide. There are 3 in Virginia, Lynchburg, Alexandria, and Richmond. And Alexandria is also doing a huge tunnel project, even larger than what we're doing. Part of Richmond's plan is also to do tunnels as well. One thing that's different between Alexandria and Richmond and the city of Lynchburg is they have certain dates that they're supposed to be completed with a program as dictated by the General Assembly. There's legislation passed that establishes certain dates that they have to be done by. So we're fortunate in that regard that we don't have a date. It's still a financially driven program. We construct projects as we have the ability to afford to do those. Originally in 1993, we had a consent order, and that plan was to eliminate all overflow points throughout the city. But as we got closer to the downtown area, it became more and more complex, more and more costly. We were anticipating that it's going to be close to $500 million to do complete separation for the remaining area that was combined. So that really was not feasible. There's actually streams that run under buildings downtown that are part of the combined system. So it would be logistically very challenging to do a complete separation project including the downtown area. So around 2009, we started looking at different options. And we did an update to our long-term control plan. And basically EPA has 3 ways that you can comply with the CSO policy that EPA established. One is complete separation, so you have no more overflow points. A second is a presumptive approach, where if you eliminate a certain number of overflows and a certain amount of overflow volume, then you're deemed to be potentially in compliance. And the third is a demonstrative approach. The demonstrative approach, basically, if you still have some overflows, which we will when we're done, we have to show that that the CSO overflows that we have does not contribute or to exceedances in water quality standards. So basically, the amount of bacteria that goes into the river does not exceed a certain amount. And so basically what we're doing with our program now for the remaining area is capturing and treating as much of the combined sewage and stormwater as we can at the water resource recovery facility. The other benefit of that is, in addition to treating the wastewater, all the stormwater and all the pollutants associated with the stormwater gets treated to a much higher level at the water resource recovery facility than if it was being discharged into a rain garden or whatever. We're treating it to a very high quality standard. So we went through the process of looking at the options, changing the long-term control plan. We renegotiated their consent order with DEQ and the State Water Control Board in 2015. And overall, that'll save nearly $300 million for the city and the citizens of Lynchburg and their sewer customers. We have, to date, for the overall CSO program, we've received over $100 million in state and federal funding. And we have great partners, have had great partners at the state level as well as the federal level to try to secure additional funding for the program. And a summary of where we are now, we've eliminated 115 out of 132 original overflow points, and we've reduced the overflow volume by 93%. And we spent about $307 million today. So we've come a very long way. We really started this back in the 1980s. And I think that's one of the reasons why our program has been successful is we've been proactive. We've been out there addressing the problem from the very beginning and investing the funding that we needed to make progress on the program. So what does that look like now? The brown area in the slides on the left-hand side, that was the original combined overflow area, or combined sewer area. It was about 6,000 acres, and when we started, we were discharging over 1 billion gallons of combined sewage into the streams in the James River. And we had 132 overflow points. Now that area is down to 900 acres, and we're discharging with all the controls. When we're done, we'll discharge on a typical year 22 million gallons of volume into the streams in James River, and we'll have 18 overflow points. Originally, we were going to have 17, but with this tunnel project, we had to actually add one overflow point. And Kevin, when he gets up to talk about the program a little bit, or the project a little bit, he'll go into more detail about that. All right, with that, I'll turn it over to Kevin.
Thank you. All right, so I'm going to give you so the CSO 52 is most costly and complex, as we were discussing. It should take us from that 93% to a 98% capture or reduction in overflow volume. It's several other options were considered in lieu of the deep tunnel that was finally chosen, like parallel pipe, storage and separation, or a combination of pipe and storage. Ultimately, they didn't quite meet all the needs of the city, and so the deep tunnel was chosen. So this is how this CSO is going to work. Currently, the existing condition is a single 60-inch pipe that runs down Blackwater Creek and eventually runs to the wastewater treatment plant after going into another pipe. What we'll end up doing is putting in a diversion structure which during a rain event will allow that excess flow to overflow into the tunnel. That becomes a conveyance and storage system down to the pump station where it can then be pumped out after the rain event has been completed, but thereby reducing the overall volume going into, or any excess volume going into the creek. Our purposes are to improve the water quality in the Blackwater Creek and James River. It reduces our overflows from 6 each year to 2 each year, changing those points where it comes out as well, which also helps us a bit. Our public, we want to protect the public health, and by doing that, one of the ways we do that is right now in excessive rain events, the sewer actually pops out some of the sewer lines along the creek side and flows into the creek that way. So it'll remove that issue unless it's the tunnel's out of commission or there was a really excessive rain event. It'll provide adequate sewer capacity for growth in Lynchburg. It actually covers roughly 70% of the city. It kind of goes into this system, so it'll actually help promote growth in the city. And it's an essential project for the completion of the overall program of CSO. So here's an overlay or overview of what the whole site will be like. It's about 4,200 or 4,700 feet of 12-foot diameter tunnel, and it ranges between 65 and 100 feet, 120 feet below ground surface, depending on the topography above. Runs from the 7th Street all the way up to about 1,500 feet north of the Hollinsville Park area. And I'll get in a little more detail of exactly where it all is here in a minute. And here you can see the profile, kind of an idea of how far underground it is. It's 70 feet at the pump station site, where it will eventually end up, and at the drop shaft about 65 feet, and then kind of, topography varies, so it stays pretty far underground. It's in good, solid, hard rock, so we were very excited about that. That makes building it a lot easier. Our schedule, we started design back in March 22. Right now, we sit about a 90% design. We're going to complete that design over the next couple of months, and we're going to go out to bid early next year in January. After selection of the contractor, we expect to start construction in May of 2024, and we have a milestone of tunnel and shaft completion by December 2026, and the final completion of the project in May of 2027. I'm going to go through a few of the activities we'll see. This is just an overview, a rendering of what the eventual final look on that U.S. pipe site, the pump station site will look like. You can see here the cutaway to the shaft below and the tunnel coming in. The electrical building will mimic the rail building on the other side of the creek in architecture, just to kind of blend into the area. And the surface of those pump station and structures will be pretty much at ground level, so it won't be a visual impact to the area. So once again, here's the U.S. Pipe site. Right now it's being used as a parking lot for U.S. Pipe. We're relocating that temporarily to another site. We estimate 15 to 20 trucks daily, but we will be having a haul route established to maintain that traffic outside of their downtown area, trying to keep all of our heavy trucking out of the city. So when we start this, we'll do shaft construction first. It always has a pre-support component where we're going to drive these sheet piles down to rock or into rock a little ways, and then conventional excavation with regular excavators of the soil down to the top of the rock, putting in some ring beam supports to hold the sheet piles up as we go. And we're also going to keep it a little high off the ground level to protect against flooding, keep it 2 feet above the 100-year flood line, just in case there's some issue while we're working. We'll be able to, we won't flood the project. So once we reach the top of rock, we're going to switch to a drill and blast excavation. And we have several vibration and noise controls in place already. We're requiring a specialist be hired to design the blast, or the blast design, to reduce the noise and vibration. There's several ways they do that with spacing and how much explosives they allow in on the hole at any time. There's also maximum allowable limits to the noise and the vibration, so they will be held responsible for their actions as well. We're going to be offering or performing pre-construction surveys to all structures within the area, within 200 feet of the tunnel alignment in either direction. So that basically what that entails is they'll come out, they take pictures of the structure, they go around, they look for cracks or anything else to be able to evaluate the impacts that we have upon that structures. And then finally, we're going to have monitoring. We've got survey monitors and vibration monitors. They will be kind of leapfrog along with the advancement of the tunnel, and they will be next to structures as well to monitor what's actually happening at those structures. I think there's up to 8 monitors at any given time on this project. And then our blasting hours, at this time, we anticipate the blasting hours to be between 7 a.m. and 9 p.m. That may be extended as we get our records from, our instruments, and as you get further in, your impacts to the surface are way lower. So as that comes down, we may allow those hours to extend a little bit longer. So here you see the ground support. On the left here, that's initial support. So that's kind of the ring beam I was talking about. It's a rolled I-beam, essentially, that will hold the structure of the sheet piles from caving in. And then when we get down to the bottom, they'll pour a cast-in-place concrete liner all the way back up. So on the right, you can see the forms that they use, and then they pour in behind those forms to create that concrete liner you can see at the top of the right-hand photo. The tunnel construction, we're leaving up to the contractor for several reasons, but whether it be drill and blast or TBM, we're on that line of feasibility at 4,700 feet. So we left it up to the contractor. So on the left-hand side, you can see our drill and blast operation. Originally, they paint out a pattern. They drill those, each one of those spots becomes a hole, and then those holes are filled with explosives. The expanding gas then breaks the rock, and then regular excavators are able to remove the rock from the hole. On the right-hand side, you can see the TBM. That excavation works in a different manner. That machine puts enough force on the face as it rotates to shatter the rock in front of it, and then that gets scooped up by buckets and put on a conveyor for removal from the tunnel. And either way it gets excavated, it'll end up with a permanent cast-in-place liner. On the left here, you can see the tunnel forms. In that situation, a bulkhead will be placed along that outside edge, and then the annular area between the rock and the forms will be filled with concrete, pumped in from outside. The center photo, you can see what the finished product looks like. Our tunnel will be very similar to that in size and shape. And then on the right-hand side, you can see that any voids that might have happened, any shrinkage cracks from shrinking or from the curing process that happen in the liner, we use a grouting program to seal that all off and fill any voids just to make sure it's safe for the future. All right. So here we have the CSO 52 diversion structure. Right here in this bottom left corner, you can see the flow will enter the center compartment. And at a certain point, it raises up. Under normal conditions, it will just keep flowing through that same interceptor and follow that same path it always has. But during a rain event, at a certain point, it will raise above this weir wall on the right-hand side, flow over that wall and into the structure that'll take it down to the tunnel. And that structure is called a vortex over here. It's right over there by the drop shaft label. It'll then go down the drop pipe into the tunnel, and from there it runs the mile down to the pump station where eventually it will be pumped back out. So that site is off. You can see here the location near Hollinsville Park. We also have a haul route that keeps traffic at a minimum, or minimize traffic in residential areas. There is estimated 4 to 5 trucks daily at this site, and that's probably a bit conservative. There's not as much excavation to be done here, so there's not as much reason for construction traffic. There will be some interruption of the point of honor trail during the duration of the construction, or the upstream portion of that construction, not the entire project. The trail will be closed to the public. The Blackwater Creek Bike Trail will have no interruption from this project. At the end of our project, that trail is going to end up being relocated a little bit further inland, or uphill from the creek side. So that'll be after, but it'll be after we're complete over there. I think. Okay.
So I just thought of a couple of things I wanted to point out to you. First, I'd like to recognize Delegate Linda Walker for being here. Thank you for coming. Again, as I mentioned before, the General Assembly has been a very good partner with the city, and we received, for this particular project, $50 million in American Rescue Plan Act funding from the General Assembly to move towards completion of the CSO program. That won't cover the entire amount of this project. We're anticipating the cost to be at least $100 million or around $100 million, maybe more, for this project, but we couldn't do it without that funding from the General Assembly. One other thing, at the pump station site down at the end of 7th Street, one other provision that we're making in the design is for odor control. We're not adding odor control facilities at this point, but if odor becomes an issue or is an issue, we can add, the way the layout will be, we can add odor control facilities to mitigate any impacts of the odor from the tunnel. Because anytime there's sewage, there's the potential for odors. And basically the tunnel is acting like a big storage tank. As Kevin mentioned, about 70%, 75% of the city sewer system goes through this one point. So this project is not only important for our combined sewer overflow program, it's also important for any type of future growth and development. Because right now, as was mentioned, when we have heavy rainfalls, not only does the sewer overflow through the permitted CSO overflow point, it also pops manhole lids along the point of our trail and comes out on the trail. So that's a big factor, and if we didn't address the capacity issues as well, then that could potentially limit future growth and development within that watershed, which is, again, 70% of the city, so we definitely need that as well. With that, we'll open it up for questions. There's actually an official 30-day public comment period starting today. So any comments that we've received from today through October, what's today? It's date 18th. Through October 18th will be part of the official comments. And part of what we have to do with DEQ and some of the conditions we have with DEQ is respond to those comments and address those to the extent we possibly can with the project. So if there's any concerns that you have, any questions that you have, there's comment cards out in the outside the room that you can fill out tonight. You can also go to the project website. We have a web page set up where you can submit comments online, and Whitney will manage those. They'll come in and we'll make sure that those are documented and addressed. And we'll have, once we receive all the comments, we'll report back out on what our responses to those comments are. So with that, we'll open up for any questions that you have or any comments that you have. Yes.
The last facility that you all built down at the treatment facility, my understanding was that was to increase your capability during big events. Is that correct or not?
It is. The problem is we have to get the flow to them. So right now we can get a lot of the flow, the combined sewer flow to the water resource recovery facility. We can actually get on a typical day, we treat about 13 million gallons per day at the water resource recovery facility. In a rain event, we can get over 100 million gallons per day come on within a few hours of the rain event starting. So that flow gets to the water resource recovery facility. So that tank that we built as part of that project was a component of the CSO program, and it does address a lot of the water quality issues. Otherwise, that flow that got to the plant, if we didn't have a place for it to go and be treated, it would just go to the river from that point. This is addressing the overflow point, CSO 52, which is along the point of our trail, back up into the system, because right now that flow during heavy rainfall, it can't get to the wastewater plant. So what will happen is this flow will go into the tunnel, and then as the rainstorms pass and flows subside, then it'll be pumped out of the tunnel back into the sewer line and then be treated at the water resource recovery facility.
And how does the volume of this tunnel compare with what you built?
It's very similar. It's actually the volume of that is about 4 million gallons, and the tunnel volume is right at 4.7 million gallons. So it's a little bit more, but it's similar.
And so there was no place to just go ahead and put another one of those big tanks, just in one place instead of having to dig this big long tunnel?
So we looked at that. We actually looked at let me get back to the site plan. We looked at doing that at different locations. We looked at it at Hollinsville Park, would have been a potential for that. We looked at the U.S. Pipe parking lot as another option for that, because it has to be adjacent to the sewer line. The problem with the U.S. Pipe parking lot is you still have to get the flow to that point, because the point of the CSO 52 is upstream of that location. Flow can't get there, so we'd have to have had some way to still get the flow to that point. The issue with the Hollinsville site was it didn't capture enough. If you look at, so I'm finding the slide, one of the things we looked at is, all right, here we go. So right here is actually the sewer line. And CSO 52 is right at this point here where the sign is, and discharges into the stream. And the sewer comes across here, makes a very abrupt 90-degree turn, and flows down towards downtown. So there wasn't any location, this area wasn't big enough for a big storage facility here. And one of the things that we did look at was value. Yes, this is a very expensive project, but we did look at the cost benefit of a tunnel versus a storage facility and what would have to go into a storage facility, because the storage facility that we have at the water resource recovery facility, it was a $60 million project. So those aren't cheap either. And there would have to be other piping and appurtenances to get the flow to that point. And also a pump station constructed because it had to be pumped out. So we did look at the overall cost per million gallons of flow eliminated going into the James River and Blackwater Creek, just come up with the plan that had the most benefit overall, and the tunnel was the option. And as I mentioned, a lot of other CSO localities are choosing the tunnel. And one of the reasons it's so deep is when you construct a tunnel, you want it to be in very solid, firm rock, because you don't want anything above it collapsing. So we have extraordinarily hard rock in Lynchburg, and we've done a lot of geotechnical work. So we've gone out and done some borings, and we have core samples at different points along the alignment, so we know what that rock looks like and what. And it's a very, as the geologists and say, it's a competent rock. It's very solid.
You mentioned only 3 cities in Virginia have this approach. What are other cities doing for their systems?
So there's only 3 cities with combined sewers in Virginia. The other cities, they may have an inflow and infiltration problem, so they may have flow getting into the sewer line and causing overflows, but it's not considered a combined sewer city. So they may be under consent orders, like in the Hampton Roads area, there's a consent order for for the communities in the Hampton Roads area to address sewer overflows, but they don't have permitted CSO overflow points. So it's different. So they'd have to go in and do a lot of work in their system to eliminate any rainwater from getting into the sewer system. That was another option that we looked at was, what could we do besides building a big tunnel in the sewer system to reduce the amount of flow getting into the sewer line and causing the overflows. But when you really start working on a sewer system and trying to find enough flow to make a difference, it's kind of like herding cats. You might have a little bit of flow getting into a broken cleanout in somebody's backyard, some flow getting into a manhole top where there's a hole in the manhole top. You might have pipes that are along a stream that have some infiltration in too from the stream. So instead of concentrating the effort in one location, like we are with the tunnel project, you'd be spending lots of money to go out into the system and try to fix lots of little problems. And overall, the cost of that is typically much higher than doing a big project like this.
Thank you.
Your other questions? Yes?
Do you know if this project is expected to help with some of the odor that along the Creekside Trail? So with alleviating and having less flow, if there will be less sewage smell along that trail?
So, potentially. So we do have, like the sewer line, there's vent pipes along the sewer line that we have carbon filters. And I wouldn't say it's going to eliminate the odor because it's still on a normal day, the sewer flow is going to flow the way it normally does. The only time that the tunnel would be activated will be during a rainfall event. So unfortunately, where there's sewer, there's typically odors, and we can try to mitigate some of that, but it's hard to eliminate it altogether. Yes?
So, I think you said this would get us up to about 95 or 98% compliance, but this will still be a permitted overflow site. So
Yes.
what point does the state say, you guys have done enough, we can't, it's not worth investing the money in logistics to get to that 100%?
So to finish our program, we'll do this project, and we have, Eric, what, about three other projects in the long-term control plan we have to complete?
Yeah, we have 3 overflow sites that will remain, and we're going to do smaller storage and some capacity improvements to dramatically reduce those
Yeah,
sites.
so that,
They're not as active as this site,
yes.
but they'll.
So I think the estimate for that work is like 25 million-ish. roughly.
20, I don't know, prices keep going up. Kevin keeps bringing us bad news.
Yeah, that's one of the things that it's very hard to predict is pricing on some of these big jobs because contract pricings have been on the rise. But basically, in order to complete our combined sewer overflow program, we'll do the tunnel and then those other 2 or 3 projects. And then at that point, we should be in compliance with our long-term control plan, and we should be able to be finished with the program. There will be a period after we finish the last project where we'll have to do post-construction monitoring. And basically what that will do is we'll have to sample and record the amount of overflow volume and basically to prove that what controls we put in place met the requirements or met what we said we were going to do in the long-term control plan. And assuming that that happens, we're actually, with this project, we'll actually should overachieve that goal by a pretty significant amount. So we should be in compliance without any problem after that.
A Facebook question is, why is the trail being moved inland at the end of the project?
Okay, so the trail, it's not being moved significantly. It's just going to be moved over to get around the structure at CSO 52 because there will have to be a structure constructed there. So part of our commitment with this project is that we will restore the trail anywhere along the alignment of the trail that has damage or whatever. We'll trail will be restored. It's just gonna be moved, I don't know how many feet, probably 50 feet or so, away from the creek at that one location where the overflow structure is, to get around that structure. But what the plan is run concurrently with the project construction, we'll have a consultant working on a trail improvement plan that will then follow. Once we get this project done, we'll do the trail improvements so that it will be something that the city can be proud of, and it'll be a good area for recreation and that type of thing. Because we know that this is going to disrupt the use of the trail, and also have an impact to the integrity of the trail, so we want to make sure that it's restored, and it's a good asset for the city for years to come. And actually, this is the overflow structure that will have to be constructed at the location where the trail is now. So basically, this is going to sit where the existing trail is, so the trail will have to be moved kind of to the north, away from the creek a little bit to get around the structure. And the other thing is that we're planning on doing is at this structure, we're going to have some educational information about the tunnel, about the project, about CSO. So we want this to be a public education piece as well. Yes.
How has this been looked at from the environment changes that we see, escalating? Has that really been fully taken into account so that we're not doing like the highway department where by the time they get a highway built, it's already, overused?
Yeah, so that's a great question. One of the things that we did when we designed this was there's a certain weather condition that we have to design for. It's a certain period of time where we had a very wet period of years that we used to calculate and determine what the overflow volume is. We've also done a lot of flow monitoring on the sewer lines, as well as sampling to determine the bacteria load and other contaminant loads in the wastewater. But a lot of that has been taken into account. For example, another thing that we did was assume that the entire sewer shed was fully developed, fully built out, so that every bit of capacity in the sewer system from a sewer flow standpoint is utilized. So basically, worst case scenario, we're constructing this to handle the worst case scenario. There will still be, as Kevin mentioned, there will still be a couple of overflows per year in a typical year. But that will be part of the process that we'll go through at the end to verify that we're exceeding. And I mentioned it a minute ago too, this will basically overachieve and meet our goals. For example, our goals were to have overflow reduced by 93% when we started this long-term control plan update. This will get us to 98%. So there'll still be some overflows, but instead of what we designed the project for, or the long-term control plan for, was to allow for 68 million gallons of overflow volume per year, and that still meets water quality standards. This project will get us down to 22 million gallons per year, roughly.
22 or 24.
Yeah. So we're overachieving by more than half. So hopefully that'll take into consideration changes in weather patterns and increased rainfall or big storm events and that type of thing.
We also designed several of the components to be up higher out of the floodplain to accommodate or to protect them in case there are larger storm events that keep coming through. That seems to be the trend right now, but long term, who knows what's going to happen. But we went ahead and raised the electrical building. We raised it up above the 500-year floodplain to protect all that equipment, and in case something like that would happen.
Other questions?
At the end of the tunnel, you got a pump station down by the pipe parking lot down there.
Yes.
And that's gonna pump from the tunnel back up to what, sewer line, going down to the waste treatment plant?
Correct.
And then those future, even our present, and particularly the future, hopefully minimum allowed 3, you have to monitor the overflow. So you're gonna have flow meters at those places?
Yes. We have flow meters, multiple flow meters and level meters inside the structures. And
Flow-
and redundant in both structures.
Flow can actually enter into the tunnel from both upstream at CSO 52 as well as downstream at the US Pipe parking lot. So it can enter in both directions. And the only time that the overflow structure at CSO 52 could be activated or should be activated is if we ever have to have the tunnel offline for maintenance and we happen to have a big storm event. So other than that, the overflow point will be much closer to the river. It will be at the US Pipe parking lot, so that also will be a benefit along Point of Honor Trail. There's really no overflow going into Blackwater Creek at CSO 52. It all will be downstream closer to the river. Other questions? Great.
Another Facebook question. Are there other more projects in mind for areas in the city after this is completed?
There are 3 other CSO projects, in addition to all the other projects Water Resources does. There's a couple along Fort Avenue, Eric, off Campbell Avenue.
Yeah, 2 projects off of Ford Avenue and another off of Campbell Avenue. The Ford Avenue project will involve some street improvements, but really I think maybe the point is that when CSO is over and this huge burden is complete, we'll be able to allocate a lot more resources to neighborhoods, and we have ongoing projects within neighborhoods to replace aging sewers and water and storms. Going on now.
So the answer is yes, there are 3 more combined sewer overflow projects, in addition to other sewer projects and water line projects that we're doing throughout the city. Any other questions? Drew, anything from DEQ?
No, I think you covered it pretty well from the discussions that we've had.
So again, we'll be very mindful of noise, dust, vibration, the various things that are related to the project construction. I mean, it will be a construction project. It's a massive construction project, so we can't eliminate everything. But the end of the project, well, I think we'll realize significant environmental benefits as well as increased capacity in the sewer system for future development and growth. Yes.
So when you put it out to bid, you're going to allow contractors to decide which method they want to use?
Yes. Yes, it's designed to where, if you looked at, going back to the alignment of it, one of the things that we wanted to keep, we figured that's the best way to get the best prices. If a contractor happened to have a tunnel boring machine that fit the criteria, that's the right diameter, that can be used for this project, then we opened it up to, we want to make sure that they were able to use the tunnel boring machine. If we had to build a tunnel boring machine from scratch to meet the requirements of this project, it wouldn't meet the timeline because it's usually a couple-year process. Most TBMs are built in overseas in Belgium or Germany or somewhere like that, and they're very costly. So, but we wanted to keep options open. We are in the process of pre-qualifying contractors as well because it's important to get a good contractor in a project like this. You don't want just anybody that doesn't have any tunnel experience. trying to tackle a project this big. So there's a pre-qualification process the contractors will have to go through. We had a meeting a couple weeks ago and had a good turnout of tunnel contractors from around the country show up at that. So we're hopeful that we'll get a good contractor and get a good price on the project.
Did I hear a rumor that the machine stays in the tunnel after, is that a rumor?
That's forever.
That's a rumor?
They're too expensive.
That's what I was thinking.
No, they pull them out, it costs about $1 million just to refurbish. So, they pull them out and reuse them, so, to his point, we're leaving it up to him, because if we had a contractor that has the right size machine that's not being used, that's great, that'd be awesome, but we don't want to restrict it to people that only have a machine, at this time, so we leave it up to them to decide which way they would like to go.
The machine is much faster, is that?
It is faster in some ways, I mean, it takes longer to put it together, so it'll take 9 months to refurbish the machine. Because what they do is they'll build them on the surface. New hoses for all the hydraulics, new cabling, new everything. They run it a few times on the surface and then take it all back apart, and then you slowly put it together one piece by piece underground. So it's a big process. I've been on one job where they didn't do it that way, and by the time they got it running, they wished they had. So.
Any other questions? All right, so, and going to your point, one of the things that those tunnel boring machines can't make sharp turns because they're very long. So the radius is, a couple things with the alignment that we did was, it's all on city property except for at US Pipe and where we cross Norfolk Southern Railroad. Everything else is on city property. So we did that on purpose to avoid having to acquire subterranean easements. We also did the alignment with the radiuses that a tunnel boring machine could make. So the geometry of that was a little tricky to avoid private property as well as fit the alignment in on city property and still be able to use a tunnel boring machine. But Stantec did a great job in coming up with the alignment. So it does swing, you can see it, the trail is over here, Blackwater Creek is here, so it does swing around to the kind of the southwest side of the Blackwater Creek, and then back across Blackwater Creek to where the CSO 52 is. Anybody else?
Just one kind of an assumptive question.
Yes.
If a contractor had a TBM that would be well suited to this job, could we presume they might also be the low bidder?
Kevin, you want to?
So I touched on this earlier. We're right at the cusp of feasibility, financial feasibility with the TBM. Generally, rule of thumb is it needs to be a mile. A mile is where they start making their money back, and it's about break even. So it's probably going to be a roughly similar numbers, I would assume, whether it's a TBM or otherwise.
Gotcha.
All right, again, if anybody has any other comments or if they want to make, you can do it online at the project website or fill out a comment card outside the room here. Also, feel free, there's plenty of coffee and cookies in the back. Grab a few on your way out. I'll do one last call for any questions, make sure we address any questions or concerns. Yes, sir.
You mentioned dust, and it made me think back to the spoils from the tunnel. And are there any concerns about the spoils from the tunnel and where they're going to be taken?
I'll let Kevin talk.
So at this time, there is some contamination in the spoils. So right now we're looking at a separate contract for a environmental company to haul that away. Right, we're structuring it now that the contractor here will haul it to an intermediate site that's not been determined just yet, but we have a few places in mind. And then that environmental group, whichever wins the bid, would then dispose of that properly. Dust-wise, it shouldn't be an issue. There'll be a dust program or a dust control program. The ventilation systems will have dust control in them as well. And then, they use water generally in the summer times to keep the dust down on site. But, that is the plan at this moment, to have another company take care of that. But it's probably the best way to get a better price. Tunnel contractors are just gonna find the first person that gives them a price and say, go, but, if we bid it out, then there's a little competition.
Okay. Thank you.
All right. Well, thank you all for coming. We appreciate it, and we look forward to a very successful project. And the plan is to get started, bid the project first part of January, and hopefully get under construction by spring.
Yes.